So can you walk through how we think the day at the hackathon will work for the adult volunteers? What are the different projects or steps they'll do with the students?
Well, once the group split off with their individual mentors, what they will be given is kind of a kit. That is the pieces that every single group will get. So that's the main board, the FTDI breakout, a set of LEDs, this little LED backpack monitor, and also like a proximity sensor.
Gotcha.
So they will get like a set of stuff to begin working with, but then they will also get a list of other types of sensors that they can pick up at one of the stations. So they have to start deciding what they kind of want to make, and once they have that decided, they can go to a station and pick up, say, a pulse sensor, and then tell the person, this is because I want to incorporate a heart rate into my design, or an MP3 player because I want it to play music.
Nice.
So once they have that, they will pick up their other pieces and then start connecting them to the computer and deciding how they want to code them. We will have on the desktop a set of code for each piece for them to start out with. This will be like the basics of getting it up and running. They can also then go on to one of the websites like SparkFun and see the types of code that other people have uploaded. And so we're hoping that they'll really start out with that basic code and then start branching off into how they want to change it and make it work for themselves.
Cool.
And the mentors can kind of help them, you know, in case they run into any issues, but also helping them, you know, brainstorm how they want this to look and the reasons they want it to do what it's going to do.
Gotcha. And then once they have their idea planned, then they will code the different pieces so that they do what they want.
Yes.
And then assemble a project?
Yes. Once they have it working, they will then start using the conductive thread to stitch it into projects. So we will have another station set up with different articles of clothing like shirts, pants. We're hoping to get purses and things like that. And that way they can start actually putting it together and having it work.
Cool. And then at the end of the day, the mentors will help them present their design or project to a panel.
They will then present their projects, and the mentors will also, you know, kind of help with the public speaking part of it, you know, really trying to sell the audience on their idea and why they wanted to make something like this and the benefits of it.
So when volunteers are working with the students, what will they have to do to start setting up to get going with the project?
The first thing they'll want to do is open up Arduino IDE. So this is the program that we use to create the code. Arduino's desktop version already has several example codes loaded in. So if you see, if I go to File and Examples, we have different ones here. So these ones will like blink the built-in LED that's on the lily pad, things like that, just so that they can get used to what they're uploading to it and how it's reading it.
And what the code needs to look like for the thing to actually work. Cool.
And because this program is used with several different models, you always want to make sure that when you first start, tell it that you're using the LilyPad Arduino, because right here we have about 20 different boards that it can load to.
Alright, so why don't you tell me how these pieces work?
Okay, so this is the LilyPad main board 328. It's made by Arduino, and it's usually used for wearable tech, so sew-in projects. It's a little smaller than an Arduino, and it's designed so that it doesn't really catch on fabric. And all of the pins are wider so that people can fit a needle through them and sew. And now this is the basic FTDI breakout. This is how I connect it to the computer so I can upload code to it. Over here I have a light sensor. So this will detect the amount of ambient light that is coming in, and then it will return it to the LilyPad as a numeric value. And then once it's returned to the LilyPad, I can decide what I want to do with that data. So for me, I have also an LED connected here. So I've decided that when the light value exceeds a certain amount, it will light up an LED to tell me.
So then how does the code get from the computer to the LilyPad to the different sensors?
We have here a USB mini cable, so we just connect it in. Once it's plugged in, the LilyPad will automatically flash to let you know it's connected. And then once you have that in and you have your code, you will click the arrow going right to upload your code to the LilyPad. It will tell you at the bottom that it's compiling the sketch and how much space it takes up.
And the light goes on.
Yep. If it flashes orange, it usually means that it's met some sort of error in the code as far as how the code is formed. It won't tell you if it's an error that you've made kind of as a human mistake. Like if I've told it a really weird light value to react to, it doesn't know, it just knows it's supposed to respond to that.
So that's just telling you if they're like missing punctuation or something in the code. Yeah.
Something that you would say grammar is wrong.
Got it.
Now, we also have the serial monitor here. So right now this is set to upload with a delay the constant light value that it's getting. And so you'll see it's kind of remaining right now in the 260s and 270s. But now if I go and cover up the sensor on the top, it should go down.
Oh yeah.
Yep, so right now we have it at 3, 3, 3.
It's not getting any light because you have the sensor covered. Got it.
But now if I use a flashlight to really beam it with a lot of light, it should respond and turn on the LED.
Which is right here?
Yep.
Ah, there it is. Cool. So what are some of the other things volunteers might need to know about just kind of the basics of setting this up to help the students?
The basics of setting this up, I would say if you run into any issues, usually the first thing you want to check are your connections. The alligator leads are used to kind of test out your circuits before you finalize and sew it in, but they also can come loose a lot. So usually my first course of action if I'm getting an error is to see that everything is connected nicely and that it's connected to the right thing. So I check in my code again, did I switch the pin, and if so, do I need to switch which pin it's connected to here?
Got it. So they would test everything out with the alligator clips, make sure that all the code is working, and then they're going to attach that to the garments and sew the circuits together with the metallic sewing thread.
Yep, with the conductive thread here.
Thank
it's
you.
actually, it's a stainless steel sort of thread.
Ah, there we are.
Other issues they may run into, like I said, sometimes when you're switching around with the code and trying to edit it, you forget that you left a certain pin as a certain number, so you make sure again that you have it connected to the right pin.
On here and on the different sensors and stuff too, right?
Yep. And another issue they may run into is the difference between a digital and an analog pin. So an analog pin can return any numeric value to the lily pad. However, the digital ones that don't start with A only return a value of high or low.
Okay.
So if you've plugged into a digital pin something that needs data, you're not going to get the right result. So if you're looking for more resources, one of the best ones from Mesophon has been SparkFun's website. For every piece that we have, they have a hookup guide which shows you how to connect it and then get it up and running with basic code. And they also will connect you to other more advanced tutorials. If you're looking for more of a background on how electricity and how circuitry works, SparkFun also has several tutorials covering that, everything from what electricity is to how it functions in circuits, and how to use things like resistors to manage the power in your project.
Cool.
Adafruit also has a lot of information on more advanced pieces. So some of the pieces we run into are ones that will connect to the SDA and SCL, which is the data and clock on our computer. And so then we're getting into I2C addresses and connecting multiple pieces to one pin and, basically talking to each one by specifying an address. Okay. Adafruit is really good with that more complex stuff, and I have also linked to their tutorials.
Awesome.